In Lesson 7-2, we're going to move into multiplying with polynomials. Now, one super easy method you can use involves a generic rectangle, as you will see here. You can see they're asking us to take negative 4x to the third times, remember that's what product means, times x squared plus 3x minus 4. To keep yourself organized, one way is to create, since we have a monomial in negative 4x cubed, we have one dimension to this rectangle here on the left. And since we have a trinomial that we're multiplying by, notice how my rectangle is 3 units long. So if I write the trinomial and the monomial on the outside of this rectangle, I can use multiplication to keep myself organized on the inside. So negative 4 times 1 is a negative 4. Remember, if we don't see a number out in front of our term, there's generally just a 1 there. And x to the third times x to the 2 is actually x to the fifth. Note this common error over here. When you are multiplying, remember we're multiplying these polynomials. When you have x squared, that's x times x. When you have x to the third, that's x times x times x. If we think about how many we have total, that is why we write x to the fifth. So don't forget that when you're multiplying polynomials, you will add the powers of like bases. So now if we go back to multiplying our negative 4 times our positive 3, we have negative 12. And x squared, or x cubed, times x. Remember there's an exponent of a 1 here. So we would have a total of 4 of them. So x to the fourth. And a negative 4 times a negative 4 is a positive 16 and an x to the third. So our final answer is negative 4x to the fifth minus 12x to the fourth plus 16x to the third. Simple as that. Sometimes you'll have like terms that you can combine, but with a monomial, that's generally not the case. Now, sometimes when you multiply two-digit numbers, if someone asks you to do 15 times 18, that might be a lot of work in your head, and of course we always have calculators. But 15 is made up of 10 plus 5. 18 is made up of 10 plus 8. If we write that in our generic rectangle, we can multiply some of these numbers a little quicker. For example, 10 times 10 is 100, 10 times 8 is 80, 10 times 5 is 50, and 8 times 5 is 40. If we add these all together, we have 150, plus 40 more is 190, and then plus 80 more is 270. So for binomials, now we're going to take x plus 5 times, and that's on the left here, times x plus 8, and that is on the top. Again, if you make your rectangle, and you don't need these boxes on the outside necessarily, this rectangle here is mostly what we're looking at, or a square, if you will. Now we're going to multiply each term. So we have x times x is x to the 2, or x squared. 8 times x is 8x. 5 times x is 5x. And 5 times 8 is 40. Notice how when I do this 40, I'm taking the 8 is the length of the top. It comes from up there, and the 5 is the length of the side. Now to combine like terms here, notice that I have x squared, but I also have a 5x and an 8x. When you use these rectangles, combining like terms is a little easier because you can see the ones that go together. They're generally diagonal. So our final answer is x squared plus 13x plus 40. Another rectangle here, some practice. So if we have, you may want to draw these lines in on the triads. I'm not exactly sure for the reasoning, but we have 2x times 5x is 10x squared. We have 4 times 5x is 20x. And 2 times 4 is 8. And 2 times 2x is 4x. So my final answer will be 10x squared plus 24x plus 8. Over here, we'll go a little quicker. 14x squared, 4x, 2 down there in the bottom, and 7x. So I have 14x squared plus 11x plus 2. They'll start to become pretty quick if you set up these rectangles. We'll do one of the triads here. 5x minus 4, it doesn't matter which side of the square or rectangle you put each binomial on. And 2x plus 1 I'll put on the top. So 5x times 2x is 10x squared. 5x times 1 is 5x. 2x times negative 4 is negative 8x. And negative 4 times 1 is negative 4. Combining my like terms, I have my negative 8x and my 5x. Remember, we take that back to lesson 7.1 where we're adding like terms. We don't have any other x squared, so 10 of those. A negative 8 and a positive 5. That would give us a negative 3x and a minus 4. I've quickly done the try it part B here for you. So our final answer will be 6x squared plus 2x minus 20. You may need to pause the video to copy those in there, but the more practice you do with these, the better you'll get. It's super important to be able to multiply these carefully and correctly. Now we've been taking a binomial times a binomial. That means a two-term polynomial times a two-term polynomial. But we can step it up a bit, and we can take a three-term polynomial or a trinomial, x squared plus 2x minus 1, times a two-term polynomial, 3x plus 4. Notice that I just made a longer rectangle here, where now I'm going to have a few more boxes to do. Same process though. I have 3x times x squared, so I have 3x to the third. 3x times 2x is 6x squared. 3x times negative 1 is a negative 3x. 4 times x squared is 4x squared. 4 times 2 is 8, and we have an x, and 4 times negative 1 is a negative 4. Now when it comes to combining like terms, as I mentioned, these boxes are so great for organizing. I've got some x squared terms there, and I've also got some x terms that I need to combine. So my final answer will be 3x to the third, and I have 6 and 4 will make 10x squared, and 8 minus 3x will be 5x, and a minus 4. Carefully combining those like terms is much easier when you have a table or a generic rectangle to do so.